Hi, good evening. Can you hear me? Hello. Good evening. Can you hear me?
Hello, sir.
Yeah, how are you?
I'm good. Good evening.
Good evening. Yeah, so after a long time we'll meet. Okay. So hope
Yes.
everything is
Yeah.
good from your side. Yeah.
Yes. Yes.
Okay, thank you. Okay, so let's go. Today I discuss about that another agriculture precision topic. Mainly you already sent me a paper about the crop coefficient. Okay, how we can easily identify.
Yes. Sir.
I try to discuss about this topic, how we can easily identify the crop coefficient using the linear model. Okay, then you can easily get the idea. Okay, so let me share my screen. Just a minute. Okay, can you see my screen? Is it visible?
Yes, it is coming. Maybe.
So basically today we discuss about this topic, how to monitor the water demand of crops to estimate the crop coefficient using the Google Earth engine. And basically when you work with the crop coefficient, then first of all we need to create a model. It's called the linear model. In the linear model we just make the relationship with vegetation density, different types of crop, and further we can easily identify the crop coefficient. And this crop coefficient is very important in the agriculture precision, because if the this value is the high, it means that this type of crop need the water demand is very high. Okay, if the coefficient value is low, it means that water demand is not high. As well as we can also get the agriculture irrigation schedule, we can also identify using the KSE value. Okay, so let's go try to explain all of those step by step, then you can easily get the idea. So there's a lot of application such as special irrigation scheduling. We can easily get the idea, the scheduling about the irrigation, and also water use efficiency assessment. We can also identify, and also crop water requirement estimation. We can also do, and also integration with the ET models such as CBEL or metric or SSE BOP. This type of model we can also integrate with the KC value. Okay, so basically, in the interpretation, suppose for the NDVI map, it's a vegetation greenness. We already know about that. It's a vegetation greenness. Or we can also say that it's one kind of crop density. Okay, suppose I have a crop field. So here I find out some place is the high NDVI value. It means that this place I find out the very high density of vegetation, or vegetation greenness is very high. Okay, or what is the KC? KC map basically it estimate the water use coefficient. Okay, KC map it's estimate the water use coefficient. Higher KC value equivalent the higher evapotranspiration. Okay, so if the value is very high, it means that the higher evapotranspiration. Okay, for this place. For the sparse crop, suppose we have the low NDVI value, suppose 0.2 or less than 0.1 or 0.1. This type of low NDVI value or sparse crop, this KCI value is low. We find out the low KCI value. It means that this type of crop is not high evapotranspiration. It's a low evapotranspiration. And if the low evapotranspiration, it means that they are not much need the water. Water demand is low. Okay, same just opposite for the dense canopy. Suppose I have a high or good crop plant or good density of crop plant. So here I find out the high NDVI value, suppose 0.8. If the NDVI value is very high, then KCI value is also high. Okay, because in the high NDVI value or dense crop plant have the higher evapotranspiration. Okay, suppose I have a good field or I have a good crop plant. So this type of crop plant I find out that high NDVI. Okay, And if the NDVI value is high, then KCI value is also high, because high NDVI value or dense NDVI or dense canopy, this type of place I find out the higher evapotranspiration. Okay, so high KC value indicate the full canopy or high water demand crop. Okay, suppose I just calculate the KC value, and this KC value I find out some place is very high. It means that this type of cropland needs the high water demand. And if you check, this is the formula about the KC. Okay, so here we find out that you can see this is the first formula, ETC equal KC multiply with the ET. So here ET basically crop evapotranspiration. Okay, and also ETC basically crop evapotranspiration. Then ET0 basically difference evapotranspiration, and KC basically crop coefficient. So now we can simply calculate this equation, Kc equal to crop evapotranspiration divided by reference evapotranspiration. Okay, just we simply just ratio of the crop evapotranspiration and also reference evapotranspiration. Then we find out the result of Kc. Okay, so this is the basic equation for the Kc. Okay, but when you create in the remote sensing we try to apply the linear model. So we simply find out the KC and also NDVI relationship in the linear model. Okay,
Sir,
yeah, please please.
that crop evapotranspiration is actually obtained from the weather data, from maybe the what is this, the teleclimate, or from
Yes,
the
yes,
modis.
yes, yes,
This crop
yeah. So
is that, and what
anyone we
now
can also use, no
the
problem.
ET
Okay,
and ET0
it,
difference
yeah,
evapotranspiration.
it can be come from your weather data. Okay, suppose ER5 reanalysis data we can also use for the as a reference data, no problem. Okay, so they are the
And the
two.
crop
Yeah,
what is the difference now between the crop evapotranspiration and difference evapotranspiration?
okay, crop evapotranspiration basically for the crop, only for the cropland. Suppose the cropland just transpiration from the water. Okay, suppose we already know about that. If you check, I will show the some example, then it will be more clear. Suppose you simply search here
Yes.
the transpiration, it's only happen for the cropland or agricultural land. Okay, transpiration, suppose transpiration transpiration in plants. So you can see this is the example about the transpiration. You can see, so this is the plant. Okay, this plant also you can see transpirate some water. Okay, transpirate some
Yes.
water. So it's called the evapotranspiration. Okay, only for the trees, so this is the tree. So this tree also release some water. You can see this tree is also release some water. Plant surface with stomata spread some water, so this water release. Okay, and it's one kind of your hydrological process, suppose transpiration. So this transpiration is only happened for the plant or trees. So you can see this type of place, this type of tree release the water. Okay, it's called the transpiration. And when this transpiration simply connect with evapotranspiration. Okay, so it's one kind of transpiration only for the trees, but another evapotranspiration is also happened, suppose for the weather, from suppose ocean or normal water body or river or lake. So this type of place also evaporated. Okay, and also release the water, just make the condensation. Okay, so this type of water
Now,
evaporate
now,
and make the condensation.
now my question
Yeah,
is there any satellite data source for crop evapotranspiration and difference evapotranspiration? Because I know the MODIS and teleclimate maybe they give the actual evapotranspiration ATC. So actual evapotranspiration can be used as a reference or can be used as a crop evapotranspiration. Or there is a way to extract the actual transport, to extract the crop evapotranspiration and reference transpiration from actual evapotranspiration?
Yes, we can also get it from here. Yeah. Yeah. Suppose in the satellite, if you check, we find out this type of satellite. Suppose one satellite, you simply search here, suppose Moody's
Yes.
Evapo. So you can see Terranet evapotranspiration and also Aqua. So I simply search that Terra. And here we find out that you can see this is the ET. ET
So,
mainly total
it,
evapotranspiration. Okay.
yes.
Total evapotranspiration. And this also you can
Yes.
see we can get the average latent heat flux. So this is the LE. And you can see the total potential evapotranspiration.
Yes.
Okay, PET. So this type of evapotranspiration you also get from here. Suppose I can say this is total evapotranspiration and also again the potential evapotranspiration. Okay, so when you just subtract these two things, then you can get the another evapotranspiration. Okay, we also get also the data from generate also from here.
Oh,
This type
okay.
of data.
Okay.
Yeah. As well as also get the some data. Suppose it's called the ER5 reanalysis data. But this data mainly it's not good resolution. Okay, it's a very, so when you want to
Yeah.
work with the large area, then we try to use this type of data. But for the Modis, we can also use for the small area because Modis is more better than ER5 reanalysis data. We can also apply, no problem.
Okay.
Okay. So now we simply generate this type of formula.
You can remove this, the pop-up window, the small pop-up window here. Yes.
Okay. So here we find out that basically EC or KC basically crop evapotranspiration divided by reference evapotranspiration. And this reference evapotranspiration we can also get from different sources. If you want, you can also use it at the satellite source, or if you want, you can also use it at the weather data. We can also collect the data. You can see that also put the one example. So in the paper he should send me, they use the Penman Montreal. This is one kind of source for the weather data to collect the reference evapotranspiration. They also collect from here. And then KC basically crop coefficient. Okay, this is the formula about that. But in this case, we try to make the relation with our crop. Okay, suppose, and how in this case we apply the NDVI. Suppose I want to make the relation KC and NDVI. Suppose I have a value KC and NDVI. So now here I just apply the linear equation y equal to mx plus c. Okay, y equal to mx plus c, and then identify the Kc equal to, identify suppose slope value, it's a slope value and it's a intercept value, y equal to mx plus c. So when I just generate this equation, then we can easily get the Kc equation. Okay, so this Kc equation is simply multiply or connect with the NDVI, basically simply multiply with the slope value and also intersect with the intersect value, simply add, then we can get the Kc map. Okay, on how to build your model. So now we talk about that. Suppose how I can build your own model. Suppose in this case we can get the NDVI values from satellite imagery. Observe the our crop field. Suppose I have a crop field, so I can simply get the NDVI values for my crop field. And further, Kc value, in the Kc value you can also get the ground measurement Kc value. It also possible, we can also monitor the Kc value from the ground, from the ET data, or you can also use the table. You can also say in your paper the FO56 table adjusted for your condition. So if you check this paper, they also use it. This paper, this is the formula Kc estimated from this. Okay, and you can see from the FAO table they also get this data, and this is the formula. Okay, etc equal to et into Kc. So from here they find out the KC value or coefficient value. And you can see they also get the KC's ratio of the ETC. Okay, and the United Nations Food and Agriculture Organization established the table of KC for the different crop. Okay, so it's the established data. Okay, so we can easily use it for our this data because it's provided the Food and Agriculture Organization or FAO. Okay, they are already provide some table KC data for the different crop. Okay, which is considered an important tool to estimate the KC. So now we can easily get, suppose I have a rice, I have a corn, I have a paddy. So they are also give this type of crop plant, a specific crop plant. They give the KC value. Okay, so now suppose I already have the KC value and I already have the NDVI value. So now what can I make the process? So we are just make the linear model. We just create the linear model. And how I can get the KC value? KC value, it provide the Food and Agriculture Organization established table of KC for the different crop. Okay, we can get the data from here and then we also use it for our specific crop. Suppose in this case there is the location area. So this is the crop plant. So in the crop plant they have, you can see the wheat, potato and sugar beet. So this type of crop plant, so this type of individual crop have a different KC value, and this KC value they collect from the Food and Agriculture Organization established data set. They are also collect from here. So now further they are make the linear relationship and make the analysis. Okay, so now how I can make the relationship about that. Okay, we'll also discuss about that. Then you can easily build your own model. So in this case our main target we try to create. So you can see they are put the this type of value. So for this time they get the NDVI value and also get the KC value for the wheat for the different times, sugar beet and potato field. They also get this type of data. So now this type of data they are used and make the relation. You can see in the relation basically this is the slope value and this is the intercept value. Just simply apply the slope and intercept value and then make the model. Okay, and then make the model. So now they are use this model and make the KC map. Okay, so let's go try to discuss about the how we can easily create this. Also you can see this is the linear relationship about this model and also calculate the R square value relationship about that. Okay, so let's go try to discuss about that how we can easily create this type of model. So now we can easily use here the Python because we can easily apply the linear model using the Python for the two data set. Suppose in this case NDVI and KCI value, we simply apply this model and make the linear model or linear equation for the NDVI and KC value. So let's go. So for that, okay, let me open my code editor. So you can easily use at the just open your terminal. Okay, let me open from here.
Sir,
Yeah, please.
in that time, in the terminal that you have opened, when I installed that Anaconda, I have two terminals. I have command prompt terminal and I have the Conda terminal.
You use
Normally,
the Anaconda prompt. You can use the
terminal.
Yeah, terminal for the Anaconda terminal because we normally two terminal we find out. One for your computer. Okay, another is for the your Anaconda terminal. So you just because we just installed all of library in the Anaconda distribution, so simply open the Anaconda prompt or Anaconda terminal. Okay, so in this terminal, I simply active my library or active my Conda. So simply right here Conda activate
environment.
Just put the environment. My environment name is that GOAI. So I already show you that how we can easily make the environment and also install the package. So just I simply open the GOAI. So because I already installed all of those. So now I just simply open my Jupyter lab in here. So Jupyter lab, just I open. Oh, sorry, I put the equal sign. Jupyter lab. So now it's open a notebook. So just I open the new notebook. So just I All right, I write the code in here. It also better. Just I import the new cell. Okay, just I start from here. So now, first of all, I need to import some important library. Okay, which I need to make the model. Okay, just I simply import some library to perform the analysis of linear model. So basically, we need the one library import numpy as np. I put the name, and also import the matplotlib to display the chart. Import matplot library dot pyplot as plt. Then also import, we also put the linear regression model. So the from I put here scalar dot linear model, and import this model. It's called the linear regression. Linear regression. And finally, we also build the another one. It's called the score or scalar matrix. We try to check for the accuracy. So scalar dot matrix, import rs square value. So just put the rs score. Just simply import. Okay, there is no problem. It means that our all of package is successfully installed, okay, in our system. I simply imported all of those. Now take the new cell. So in this new cell, in this case, suppose I already have the NDVI value and also have the KC value for individual cropland. Okay, I already have. So in this case, I simply randomly import this type of NDVI value and also KC value. I simply import because suppose I already have this type of value. So I take a variable, suppose NDVI, and just I simply make a array. For the array, we need the numpy library. So I call the np dot array. I just make a array and store it all of NDVI value for a specific cropland. Suppose 0.23. Suppose this is my NDVI value for the specific cropland. Suppose I have the another one 0.5. Suppose I have another one 0.56. Suppose I have another one 0.68. Suppose 0.
But if I have them,
Yeah.
I have them in CSV file.
Yeah, same,
and import
same,
is
same,
the
same.
CSV file.
Yeah,
Is
that,
it?
yeah. Suppose I have a CSV file, all of data. I have a two column. Suppose one column is stored for NDVI, another column for the KC. So we can simply import the CSV file and then also work. No problem. Yeah. 0.74. Suppose then I put here the 0.78. Then put here suppose 0.81. Then put here suppose 0.83. So I simply imported NDVI. And now for this NDVI, for this place or for this field, what is the KC value? I simply import the KC value, all of KC value. So I simply put the KC equal np dot array, and same process I simply import the your KC value. Okay. Suppose for this first NDVI, I find out the KC value, suppose 0.20 for the first cropland or crop area. Suppose this is the potato, or this is sugar cane, or a specific any other crop. And then suppose I find out the another 0.77. Suppose I find out the another one 0.62. Suppose I find out the another one, suppose 1.0. Suppose I find out the one 1.02. Okay. Suppose then I find out suppose 0.96.
Sir,
Suppose, yeah, please.
I'm just asking the question myself that if the aims of this model is to estimate the KC value, is it?
Okay, so in this time, this KC value we can also measure from
Yes.
our field. Okay, suppose for the specific geolocation. Okay, for the specific cropland area. Suppose I have already
Yeah.
NDVI value, and same cropland or same area, we also compute the NDVI value 0.23 or
Yes.
0.5, and same place we try to check what is the KC value. We simply measure the KC value.
Yes.
So now my target is
Yes.
that I want to predict the KC value based on the NDVI. So I make a relationship KC and NDVI. So in this case, we try
Yes.
to make the y equal to mx plus c. So we try to put y equal to mx plus c. It's called the linear equation. In this linear
Mm.
equation, here y is the kc value. Okay, y is the kc value. Y is the kc value, and
Mm.
m basically slope value, and x basically ndvi value. And I already have the ndvi. Suppose I have an ndvi map. So this ndvi map, how I can convert into kc map? So for this, we need to apply the linear model y equal to mx plus c. Here y is defend, y is defend, and x is independent. Okay, and I want to
Mm.
predict the y basically kc. So we can simply write y equal to suppose kc equal m multiply n dvi, okay, plus c. So now this is my target. I want to compute this equation, and in this equation I want to identify for m value and c value. Okay, from the linear model I just identify m value and c value. So further, this m value and c value I want to apply on my ndvi map, and then I can easily get the kc map. Okay, so our main target is that we just make an equation. Okay, and how I can make this equation? We can just use this data ndva and kc data and make the linear relation y equal to mx plus c, because m and c basically slope value and c value is same. Okay, m value and c value is the same for any data point. We find out the m value and c value is the same, but this ndvi value is the different, and if the ndvi value is changed, then kc value is also changed. So in this equation, if I know the c value and I also know about the m value, and I already have the ndvi value, then I can easily predict the kc value. Okay, I can easily predict the kc value, and this kc value I can easily, this equation I simply interpret with my ndvi equation, and I can easily predict the kc map. And from the kc map we can easily get the different information. Suppose high evapotranspiration, for the high evapotranspiration indicating about that high water demand cropland. Okay, and low kci value indicating about that low water demand cropland. We can easily get the idea from here. Okay, so now we get this equation, and now we try to compute. Suppose in this case, it's independent and it's dependent. Okay, this is the independent, and independent always will be one dimension. Okay, it's always one dimension. If you check, suppose if I just print ndvi, just I print. Okay, let me run it again. Just run, and also print the ndvi. So again, so you find out this type of dimension array, it create the ndvi value. But when I reshape it, suppose I put the reshape value, reshape into -1 to 1, just I reshape, and now if I just run, so now you can see it show this type of dimension. Okay, so you always remember that independent variable and independent. So in this case x is independent. Okay, and for my equation ndvi is the independent, and independent of variable always is the one dimensional. And how I can make the one dimensional? Just use the reshape and use the -1 to 1, then it just show this type of dimension. And kc is the dependent, it's not need to change, we are just keep the same. If you check the kc and run it, so you can get this type of value. Okay, not need to change anything, but independent. So in ndvi is the independent variable, so that's why I simply reshape it. Okay, otherwise kc is not need, because we predict the kc. Okay, so now we simply call make the fit linear regression. Okay, so we just simply call the linear regression model. So for that I take a variable, suppose model, This variable, I simply import I already import the one model, you can say linear regression model. Just I copy and paste here. Okay, I simply call my model linear regression. Okay, so now this model I want to train with the data NDVI and KCI data. So how I can train? For the train, just call the variable name model and apply the fit function for train this model. Okay, so I just call the NDVI and also call the KC. Just I simply put the two column in my CSV file which stored the data NDVI and KC. Just I run it. So now this model is trained, and now I can easily identify the coefficient value and intercept value. If you check, just call the model. Suppose I take a variable a equal, I call the model. From this model, I want to check the coefficient value. So just apply the function coef coefficient underscore and put the 0. Okay, so now if just run the code, so now this a value, if you check the a value, it show the one kind of value 1.45. So this is the coefficient value. Okay, or it's called the slope value. We find out the slope value, this type of slope value. So now we want to identify, suppose intercept value. For the same process, just take another variable and call your model, and from this model I want to identify intercept and run it, and also print the b value. So we find out this is the intercept value we find out in here. Okay, this is the intercept value we find out in here. So now I just simply identify coefficient value and intercept value. So now I want to check for r square value from my model, and I want to predict. Okay, so let's go try to take the another variable r square. Suppose I just call the r2 square library function and just put here the kc. Okay, kc comma, and then put here that call the model dot predict NDVI. Just run it. So now you just print the equation. Suppose print the final equation. Suppose I just write the notation. Suppose equation kc equal a, it's come from a value, and I take the 3 digit after decimal, 3 digit. Okay, this value just multiply with NDVI. Okay, and plus intercept. So I just simply define the intercept value. So it's come from the b variable, and I take the 3 floating number or 3 decimal number. Okay, so equation is simply print. Okay, just run it. So I can, so you find out this type of equation in here. So you find out kc value, you can see this is the m value and this is the slope value you find out in here. Okay, this is the m value and this is the slope value. Okay, and I already have the NDVI value. So now I can easily predict the AC value. So it's one kind of equation. As well as if you want, you can also make the R value. You can just print. For the R square value, just print. Suppose coefficient coefficient of determination. Coefficient of determination, it's the r square value. R square value. And these values come from this variable, r square variable. So r2 variable. And I take the first three floating number. So run it. So we find out against this r square value, we find out that. Okay. And if the r square value is the more strong, it means that your data set is more accurate, your accuracy is also more accurate. Okay. And if the value is the low or negative, negative mainly just we find out the vice versa. And if it negative positive value, a strong relation, we find out the strong relation if you find out the positive value. And if the r square value is the 0, it means that no relation. So we find out the strong relationship in our data set. And this type of things we can also just make a plot and display the result. So how I can make the plot for the plotting? Just simply just call the plt matplotlib.py as plt. I just call the plt and apply the scatter. I make the scatter of ndvi data and also kc data. Just run the code, so you can find out this type of chart. If you want, you can also make the more style. You can just make the fitted line also. Okay, so I just put here suppose color. I put the color as a suppose green color. Then I put here suppose you can also add the label. I put the label suppose label will title. You can suppose observe. Okay. And if you want, you also put the fitted line. So for that plt dot plot, call the ndvi, then just apply the model, predict ndvi. I put the color, equal red. I put the label, suppose it's a fitted line. Okay, so you find out this type of fitted line. Okay. As well as we can also add it, suppose plt dot x level, and at the x level title, suppose I put that it's a x level basically ndvi. And also plt dot y level, so I put that it's a crop coefficient or kc. Then we just add the title, plt dot title. Put the any title. I put the title, suppose linear relationship. relationship between NDVI and KC. Then also add plt dot listen. You can also add the listen of the chart. And you can also apply suppose plt dot grid. Just add the grid. Just put the true of boolean operator true, and also plt dot show, and then run it. So like as we find out, this all of this is added in our title. Also add the X level, Y level title. Okay, then we can easily get the observed and also fitted line. Okay, and this is our main equation y equal to mx plus c. So now how I can use it? Suppose I just generate this type of linear model, and now this model how I can implement on my data set. Okay, and then identify of KC map. Okay, so for that we are just come to the Google Earth Engine code editor after creating our model. Use the NDVI data and also use of the KC data. Simply use and then identify coefficient value and also identify intercept value. So now we can simply apply.
Sir,
Yeah, please.
is it possible to export this graph as PDF or image?
Yeah, it also possible
from the Jupyter.
Okay. Now you can also download the PNG file format or also download the PDF file format. Okay.
Okay, and you may try maybe to show me later on when we have this data in the CSV, both two columns of KC value and NDVI.
Yes.
You'll show me later.
Okay. Okay, so now we try to check how we can easily add this model. Suppose I find out this type of equation. I want to apply this equation on my model or crop field model and then identify for KC map. Suppose this is my study area. Okay, suppose this is my study area. So I use this place different types of crop NDVI value and also KC value. Suppose I just have. So now I just apply the KC map for my place and identify which cropland need the more water demand. More water demand means that it the more evapotranspiration. Okay, and what is the evapotranspiration? Evapotranspiration means release of water. Okay, release of water. So suppose I find out this cropland have the more evapotranspiration. It means that this cropland area need the mass water demand. This cropland area because their evapotranspiration is very high. Okay, so it's mass more water demand is more water for this type of cropland. Okay, so let's go try to identify. So now first step is I already take the study area because I just collect some data from here NDVI data. So you can also place any types of cropland area, no problem. So first step we need to call a satellite data. So from this satellite data we just simply calculate the NDVI. So in this case it's also better we try to apply for Sentinel-2 because it's the high resolution, we can get the more better map. So I just apply Sentinel-2. I simply search or go to the browse data catalog and then import your data set. Sentinel. And it worked for Sentinel-2 multi-spectrum experiment. And if you check, I want to work with suppose surface reflectance data. Just copy the snippet ID. So now we simply load satellite imagery. Okay, you can also apply the Landsat also, same process, or any other satellite images. I just simply import and give the variable name suppose S2. Just simply put here filter bounds with my study area AOI, then filter date. So I take the data, suppose year of 2024, or for the crop season area, or I put here suppose 2025 1st January from year of 2025 03/31. So I take this type of, suppose this is the crop season area, or any specific agriculture season, we simply put the time. And now filter, I want to filter suppose cloud cover ee dot filter dot less than. So just put here the image property. I choose suppose cloud pixel per sentence. Just copy the property name and paste here, and I put the value. Suppose I take the 10%. Right? So now let's check how many images are available. And run the. Okay, so we find out the 28 images for this place between this time period. Okay, so now in this case, first of all, we try to identify NDVI. We just make the NDVI, and then when I get the NDVI, then I can easily apply the KC function. Okay, basically this equation is simply applied in my model. So let's go. So how we can apply it? So in this case, I want to create the NDVI map for every image. Suppose I have total 28 images. So I want to create the NDVI map for every single images, not create the median or mosaic. I don't use the mosaic other. So I create the NDVI for every images. So how I can do it? So for that, you need to apply the function. So we create a function, or we create a tool. So this tool help you to compute NDVI for every single images. So let's go try to create a function. So just I put the function keyword, and I put the element name, suppose img, and I put my argument. What is my argument using this element? So my argument is that I want to make NDVI. So take a variable, suppose NDVI equal. If you check NDVI equal, I just put here call the element and apply the normalized difference between two band for Sentinel-2, near infrared B8 and B4, and I rename it dot rename. I put the rename as the NDVI. Okay, so I find out the NDVI. So now I want to apply this model. So in this model, if you check, we find out this type of equation. This type of equation we find out in here, but in this paper we just use this model. If you check this, there use the equation. So in this time I just take the manually value, so that's why you find out, but I want to use it. Okay, I want to use this model. But how we can really create? Just apply your real data. So when you work with the real data, just apply this this process. Okay, then we can easily get the slope value and intercept value. So in this case, I want to apply this equation, and then I want to identify for the KC. Okay, but when you work with the real data, then try to apply the same process, then we can get the more better result. Okay, so let's go try to apply this model which I gained from this research paper. Suppose in this time they are use this equation KC value equal 1.259. so this is the slope value. This slope value multiply with NDVI result. So take a variable, suppose KC equal, I just call the NDVI, and it's multiply with this value. So this is the slope value and add with intercept value. Intercept value will be 0.034. So this is the C value, and then we just put the rename function. Rename, I put it's a casing or casing. Okay. So now it's
Sir,
yeah,
sir,
please,
I have
please,
a question.
please.
I have a question, please.
Yeah.
Please. The, those NDVI values that we have used to calculate the slope and the intercept are different from these NDVIs that we have created from this image, are different. If are different, the area also are different or are value of the same study area.
Okay, so it also
You get my question?
yeah, I got your question. So in this time, this model, linear model, it's basically not much vary for the similar crop. Okay, suppose this is your place. You can suppose this is the place. I just get the data for the suppose sugar cane. I want to cultivate the sugar cane in the other place. So I can also use this value. It's not much more difference we don't find. So almost similar
My
value we find
question,
out. Okay, and you can also use
my
it.
question is,
Yeah.
I'm just confused with the data, the NDVI value, because this is slope and the intercept, we have got them from the NDVI value, is it?
Yes, 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 yes.
And also here in Google Earth Engine, we create the NDVI value using this Sentinel-2, is it?
Yes, 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 yes. So basically,
So
we
my question,
identify this KC value. We identify based on the NDVI value. Okay.
yes,
Yeah. So I have a NDVI map. Okay, and I already KCI value is limited. Suppose just I have the KCI value only for this specific cropland area. But NDVI value or NDVI map I find out for the whole study area from my satellite imagery. But KC value I have the some specific cropland area. Okay. So what can I do? I simply use this same area. I want to identify NDVI value. Okay. Suppose you can see in our in this notebook you can see. Suppose I have this KC value. So for this KC value, what is the NDVI value I simply gain? So what is the case for this KC value? What is the NDVI value I can gain? So for this KCI value, what is the NDVI value? Okay, I have this type of value. So now from between this type of value, NDVI and KCI, I simply make the linear model and identify for the KC. Okay, based on the NDVI. So in this case, NDVI is the independent and KC value is the dependent because KC value is depend on the NDVI value. And I already have the NDVI for all of place, but KC value I don't have all of place. So that's the reason I just use the NDVI and predict the KC value. Okay, for the whole study area or whole all of cropland area. Okay. Okay, so let's go. I just show you the result, then you get the bit better idea. So now I simply, so this equation we simply collect from our linear model. Okay, so this equation it's come from the linear model. Okay, and how we can make the linear model? So for this linear model we need the ground truth KC value and also have the end. How I can get the NDVI value? We can easily get the NDVI value. Okay, suppose if you simply make the NDVI map, suppose this is my one training sample, this is my another training sample, so I can easily extract the NDVI value for this type of place. Suppose this is my station. Okay, so I simply visited this type of point and I just stored the NDVI value or stored the KC value, okay, from the field. And then I simply come in the Google Earth Engine and further I also extract the NDVI value for this type of place and generate this type of data. Okay, for this, suppose for this KC, for this coordinate we find out this KC value and also find out the NDVI value. For the similar coordinate I find out the KCI value and also find out the NDVI value. Just we make the data set. Okay, for the similar coordinate or similar point, and further we just make the linear model, and this linear model I find out the equation, linear equation. So this linear equation we just use and predict the KC for the whole study area. Okay, all of cropland area. Okay, so now we simply apply, suppose this KC. So we are just return this image, add bands, add bands of uh, NDVI and also add bands of AC. Then apply the copy properties. So copy properties is element and system type string. So now what happened if you just simply print the S2 all of image. Oh, so this is the function we need to connect with our collection. So for the connecting, just use the map function. So put the dot map bracket start and close the bracket. So now run the code. So now every image it compute the NDVI and KC. Uh, what's the problem? System. No, we just use the okay. So now if you check, we find out the result. All of images compute KC and NDVI. Okay, we compute the KC and NDVI. Okay.
Oh, now, sir, I understand.
Yeah.
Now, those NDVI value we used it to calculate slope and the intercept
Yeah.
are just some, not from all the area, but we pick only the some point, is it?
Yes.
But
yes.
in this, it means the whole study area.
Yeah. Because
Okay,
KC value is not have all of area. I have some few KC value, but NDVI is available for the all of area. We can easily collect from the satellite. But KC value is for a specific station area. Okay.
So you must have an DVI in the same area which you have the KC value.
Yes.
So in the other area that you don't have KC value, that area is now we come now to estimate now from this model. Okay.
Yes. So now this model is estimate suppose other place. Suppose I don't have the KCY value for this proplan area. So then it's easily predict by the slope and intercept. Just use this linear model and then predict the KC value. Okay.
So that means it is impossible now to estimate KC value if you don't have the ground truth of some of the area of KC. You must have at least some point of KC, is it?
Yes. And this KC value we can also generate from not only for the all-time ground. Suppose you can also use some reference data. Suppose in this paper they are used at the for the individual crop. Suppose for the wheat or sugar beet or potato, they are use some data. It's collect from the food and agriculture organization. Okay, table. You can also go to the website. Then you also get the some data for the individual crop have the individual KC value. Okay, it's the established data. You can also use it as well as if you want you can also get some source data. Suppose Modis app you can also get from the KC data, also get from the Modis evapotranspiration. From this type of data set you also collect the KC data. Okay, but it also better if you have the chance to collect the data from the ground, it's also more better. Or you can also use the food and agriculture tablet data. We can also get the data from here. For the individual crop have the individual KC value and it's the fixed for any study area. Yeah, please. Yes, please. Yes, can you hear me?
Hello.
Yeah, so suddenly electricity was
Now I
gone.
can
Okay,
hear.
okay, so let's go again, continue. Yeah, please.
Yes, I've asked that those file data, file KC from Food and Agriculture
Yeah,
Organization
yeah.
are specific for some area or for the who for us are fixed in any region or for a specific region.
So it's not fixed, it's just for the cropland. Suppose for the sugar cane cropland area, so this is the fixed value. Then potato, then other crop have the specific value, have the specific KC value. Okay, it's fixed for any study area. You
Okay,
can also apply, no problem. Okay, just we know about
okay,
the field crop. Suppose this field is the potato or sugar cane or which crop this field, then we can get the KC value from
okay,
the food and agriculture or this website. We can get it and then we can just use it. And this type of crop plan or field, we can easily extract the NDVI value, okay, from the satellite data. Further, we simply develop the model, okay, and then model we simply implement in the code editor and we can get the result. Okay. Okay, so now let's go. We try to estimate the other part. Okay, so we find out. So now suppose I want to display some map. Just apply map dot add layer and call the S2. I put it there on S2 two bands. I apply and clip with my study area, which is AOI, and run the code.
you can't use the medium or mini here
So in this time we
in
just display
map.html
all of single image. We try
bands.
to just add using the two bands function. It just mainly help you all of bands connecting at the same time. Okay, so let's we try
Okay,
to check. Okay, so if you check this layer, so you can see it show this type of, so you can see this is the band. Suppose I'm show you the single band, you can see. So this type of band we find out. Mm, so I want to just check only for that. So okay, so let me just filter the band, then it will be more better. We are not all of band, so I have to
yes,
select only for the KC
yes,
or NNDVI. So put at the select
yes,
and apply the make a list. I put at the KC
and
and NDVI band.
small letter,
Yeah,
yes.
and NDVI. Dot. So now every image we find out the two band KC and NDVI, and we can also display the map, okay, for the every time period. So now from here we can get the idea which date or which time which cropland need the more water. We can get this type of information from here. Okay, suppose just I focus, and if you just click on here, just I display for the one band. So you can see this is the now all of those show KC and NDVI. Suppose you can see this is the first, this is the time we find out the KC. So I'm going to add the color for this time. Suppose stressing at 8%. Okay, so it's a single time single date imagery result, okay, for this 2022 25 0 2nd January. Okay, 2nd January for the scenario for the cropland. You can get the idea. So you simply add the color. Okay, so in this time, suppose for the KC, suppose I put the low value, show the blue color. Then suppose get at then I show this type of cyan color, or get at then I need to show this type of yellow color, and use suppose this type of green color. Okay, and apply. So now this type of green color indicating about the high value of your evapotranspiration or a high demand of water. Okay, this type of land, or this type of green color indicating about the high KC value. And if the KC value is high, it's indicating about the high demand of water, because this place have the
Water.
high evapotranspiration. This type of cropland area, basically high evapotranspiration means that it releases the high water. Okay, so that's why this type of place the demand of water is very high, but this type of place is low, also this type of others is low. So we can find out this type of place or this type of greenland or green color indicating about the high demand of water, because kc value is very high for this type of place, kc value for this type of place and for this time. So you can also check the all of time, suppose which time you need, so we can simply select the time and display the result. Okay, or if you want you can also create suppose composite, suppose all of image 28 image, I just make the composite and display the map, it also possible. So for that we simply just add, suppose just I comment it and I create suppose composite and display the result. So let's go and try to show you that. So for that just take a variable, suppose I put the variable name is suppose median and I call the s2. This s2 simply make the median composite and clip with our study area, suppose aoy. And now map.add layer, suppose map.add layer, I suppose I want to add the layer for ndvi and also kc. So median I just simply call and then apply here select function, select the ndvi. Okay, and I'll say add the color plated, suppose mean, suppose 0 to max for 1 and add the color plated, make the list, suppose I put here that brown color for low ndvi, then yellow, then put here green. Okay, and I put the layer name, it's ndvi. Same procedure, just apply and make the kc, just I copy and I select for band of kc which I already generate and I put the value for kc, suppose 0 and 1, suppose I put the 1.4 and add the color, suppose I put the color for low, suppose put here the blue, then put here the get it, then put here the cyan, then put here the suppose yellow and put here the green color and put the layer name and suppose it's a kc. So now at the same time you find out the two map, sorry, put here in here kc layer name, just run. So now we find out the ndvi and also find out the kc at the same time. Okay, so high ndvi value, it means that dense vegetation or good vegetation, and we find out the high ndvi value place, we find out the high kc value. So if you check the result, this is the ndvi, so let me just stress when it look more perfect, but this type of green color indicating about the high ndvi value or good vegetation or dense vegetation or dense cropland area or dense cropland, we find out this type of place. Okay, this type of green color indicating about that, this type of, so you can see this type of place have the good vegetation, okay, or dense vegetation. So that's why this type of place is the high evapotranspiration, and if the evapotranspiration is high, then we'll also find out the kc value is also high. So then if you check the kc value, just expressing the result look more perfect. So green is indicating about the high kc value, so this type of high kc value indicating about the high demand of water. Okay, this type of place.
Sir,
Yeah, please.
I saw that the area where there is low vegetation, low NDVI, it maybe requires large amount of water than the high vegetation area, or it is vice versa.
So it's vice versa. Suppose low vegetation area, we find out the low value of kc. Okay, so Kc value is,
Yes.
suppose sparse vegetation, we find out the low value of Kc. It means that their evapotranspiration is also low. So if the evapotranspiration is the low, it means that for this type of cropland, not much need more water.
But in reality, the area where there is low in DVI, it means maybe we need to water it, that area, than the area which has high vegetation. Is it? Or it's different?
It's different. So basically in this time, the Kc value is help you to identify for it, to make the relation with the dense vegetation, okay, or good vegetation. So we can also get the idea, suppose this type of place is, it's so very high Kc value, it means that their productivity rate is also high. But you can see it show this type of blue color, it means that it's the sparse vegetation, it not much good cropland, this type of area. So that's why it show the Kc value is the low, because it's the sparse vegetation, not dense cropland. But this type of green color indicating about the dense cropland. So that's why their Kc value is also high. And if the Kc value is the high, then we find out the high evapotranspiration. High evapotranspiration because
Loss
it's
of
the,
water.
yeah, and need the lot of water for this type of, demand is very high for this type of cropland area. But this type of blue color, it's not much this type of cropland area. Also you can see this type of cropland. Okay, so just make the dense vegetation. So how we can identify dense vegetation? So in this case we are just apply the ndvi and identify what the dense vegetation and sparse vegetation. So then we simply apply the kc model. We generate the take the ground truth data and make the kc model, and further we simply make the relation and identify if the kc value is the high, it means that this type of place is the more evapotranspiration. And if the evapotranspiration is the more, it means that it's the dense vegetation. And when the evapotranspiration is more, it means that this type of cropland need the water demand is very high. Suppose it can be sugar cane, it can be or rice. Okay, suppose some cropland have the different types of demand of water. Some cropland area need the more water irrigation, some cropland area need the low irrigation. Okay, so it's the different on the cropland area. So that's the region. FAO, Food and Agriculture Organization, they provide the specific cropland have the specific value of Kc. Okay, so then we can easily measurement from this Kc value.
There is a fixed range of Kc value. Example, the DVI, we know it is -1 to 1. Then Kc value, maybe we have the highest and the lowest. Is there a fixed range?
A Kc value is always fixed for that. Okay, for the
I mean, my
cropland.
question, NDVI is ranging between -1 and +1, is it?
Yes.
But Kc value, I think I see the value is just vary. There is no fixed. Maybe the lowest Kc value maybe -1, and the highest maybe 2 or
Yes. So
positive
if you simply search
3.
suppose POW Kc value, so you can see the single crop. You can see Food and Agriculture website, chapter 6, single crop coefficient. Okay, so from here you can get the data, and it's the fix for any estuary area. So you can see this is the formula. Okay, and you can see this is the different types of small vegetable. Okay, so you find out. Okay, and you can see also find out the plant that they also provide. Okay, for this type of value, so also find out. Okay,
That is from FAO, is it?
yes. Okay, you can see. So this is a single crop.
It is free available.
Yeah, yes. You can say the dual crop. So you can see the Kc value for the broccoli. You can see different types of vegetable crop. We find out the Kc initial value, Kc mean value, or Kc in value. Okay, for the initial time, suppose for the growth stage. Okay, suppose planting stage, then peak of the growth stage, and also harvesting stage, mainly end. Okay, so different three stages of the crop phenology, we find out the different value. Okay, so simply and we can
Okay.
easily get the result. You can see for the initial, then peak of the growth, and also harvesting. Okay, so this type of three KC value you find out from here. Evaporated, you can see maximum amount of the water that can be evaporated. Soil evaporation reduction, Kr value also you can see, right? But in this we just talk about the KC and then work with that. But you can see there is a lot of other parameter we can also connect with our model. Not only for the KC, we can also use here the KE model. KE, you can see the different types of parameter. So you also read this type of that, then get a lot of information about the crop water demand calculation or the crop coefficient. Okay, so again the calculation of the crop coefficient under the pure irrigation. It provides a lot of information. Mhm. And further simply use on your study area and then get the result. Okay, so now we just talk about that how we can easily make the time series. Suppose when it's very high demand of water, when the low demand of water, so how we can easily determine this type of things. Now we talk about that. Okay. And further we can simply export this type of map and also work the arc map or user software to work with, make the proper map for your research paper presentation.
Sir,
Yeah, please.
in this method that you have used, we didn't use the reference evapotranspiration and the crop evapotranspiration. Is it?
Okay, basically this FAO data called the reference, your reference evapotranspiration. Okay, it's provide the ready-made
Mm,
data. Okay, suppose it's already calculate the KC for individual crop and provide the KC.
mm,
So don't need the, but it also possible. Suppose you have some other sources, you can get that this type of data.
mm.
So then we can also compute the using the formula and identify the for the KC value. But in this time, this FAO, this data set is already work. So not need to change. Just directly you can use the this type of value.
Okay.
Okay, so now we talk about the time series charts about how you can easily make and identify for the KC. So it's very easy. Just apply the same process to identify which time need the more water demand on the cropland area. It means that suppose this cropland when need the more irrigation. So we can easily identify from the KC value time series chart. So we already make the image collection, total 28 image collection. Just I call the S2. So just I call the S2 and then select the band of KC. Region is my study area. Suppose AOI. I want to compute suppose maximum band of KC value, maximum KC value. So EE dot reducer dot max scale. So 10 meter I keep for this. X property we just put here system time start. So finally simply print the chart and run. Okay, so now
Sir,
yeah, please.
please, can you go back to Jupyter? Sorry, to
Yeah,
Jupyter.
yeah.
Yes, in that data, that KC value and the NDVI, yes. Now, this means these KC values, this 0.2, 0.77, 0.62, 1, these are from different crops, is it?
Yes, 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 yes. Different crop.
If if it is the same crop, the value should be one, the same, is it?
Yes, suppose KC value, suppose specific value, but NDVI can be different.
The NDVI can be different, but the KC
Yeah,
value
yeah,
for
yeah.
the same
Yeah,
crop,
it's
if
same,
you
same,
want to
same,
estimate
same,
from the,
same.
will it be possible maybe to put the value 111? The correlations will be no correlation.
Suppose in this case, this KC value can be same for different vegetation, but NDVI value cannot be same for the different vegetation. Okay, suppose I
Can
find
you try
out,
to
yeah. Suppose I find out this
can you
value
try to
same 1.0. Suppose this
0.2 or
suppose 1.0
yes,
and 1.0. So it's a similar crop, but I find out the NDVI value is the
the whole
different.
column?
I find out the different NDVI value.
Yes.
Okay, so it's also possible. It also possible.
Can you can you put 1.0 in the whole column of KC here? And it runs the 426.
Okay, so I put here suppose 3 1.0. Okay, 1.0. You can see 1.0. Suppose it's a
Yes.
rice. It's a rice. It's a rice. Okay, similar KC value, but different NDVI value. Okay, so
Yes, the whole column I want, the whole column of KC, please.
which one?
This whole column of KC. Yes,
Yeah,
put it 1.0, the whole column.
or similar crop.
Yes, similar crop, maybe
Oh,
sugar
okay.
cane.
Okay,
You
okay.
want to estimate from the
Yeah,
sugar
yeah, yeah,
cane.
yeah. Understand, understand. Yeah.
Yes.
Okay, similar. So
Yes.
now we just run. Okay, so we find out, you can
You see,
see. Yeah, you can see.
no correlation.
So it show that R square value is that 1.0. Okay.
Yes, no correlation.
Yeah.
It is one means 100%.
Yeah.
Okay.
But when you work, you just simply compare, then it will look more perfect. So different
Yes,
crop.
yes.
suppose rice, sugar cane, or jute. Suppose in this time in this field, it's not cultivate only for rice. It's cultivate the different types of crop. Okay, and different type of crop have the different demand of water. And if you check, we find out this type of result for the KC. So when the KC value is the high or low, we can get the idea from here. Okay, so now these things we can also identify also. Suppose this is my cropland area. So now I want to make the scatter, and I also make the correlation. Okay, I want to make the scatter value between KC and NDVI. Suppose from this two map, I simply collect suppose 500 sample training sample randomly. Okay, or if you want, you can also take the specific cropland also, but I want to take the randomly. Suppose 500 training sample, I extract the values for NDVA and also extract the values for KC. And further, we can also display the scatter chart. And from here, we can also get the relationship also. So for that, it also possible. If you want, you can also take the specific crop plant. Suppose you know this is the rice, this place is the rice, or this is sugar cane. So then you can also get the training sample from here. Suppose just click on here and take the training sample for suppose rice or sugar cane. Just simply take this type of training sample. Or if you want, you can also take suppose randomly. Suppose just take a variable PTS or point, and I take the random point. So just put here EE dot feature collection dot random points. Okay, it's create the random points on my study area. Suppose 500. Okay, so if you just map dot add layer, so if you check, it added the total 500 points on your study area randomly. Okay, so now what happened? Suppose I want to extract the all of 500 points. 500 points mainly your extract the information for KC and NDVI, and further I want to make the correlation, this type of values.
You have added 500 point randomly.
Yes, 500 points randomly I just generate. You can also put the 800, so you can put any value. So I just create the 500 points for my study area. So now I want to extract the value for NDVA and the KC. So take a variable. Suppose I put the variable samples, and I want to extract the samples from the map. So just I call the median. From this median, I extract the pixel value of KC and NDVI. So just use the select function and set the band of NDVI and KC. Okay. Then simply apply the dot sample regions and extract the value from the points collection. Okay, so first of all, just simply put here that collection will be PTS. Then scale, I put here the scale, suppose 10 meter. Okay, so now I want to, if you just simply print and easily display all of result, mainly extract the values. So 500 training sample, we get the result. You can check the two value. This is the NDVI value and this is the KC value. So now I want to use all of those and make the uh, correlation or linear relationship. So for that, or also download this type of data, okay, to use the in the Python environment, or download the CSV file. Okay, so let's go try to just do it for this type of data extracting. So for that, just take a variable, suppose chart. I want to create a chart. Put here UI dot chart dot feature dot by feature.
Control space.
So just put here feature by feature. Okay. Just
Control
call
space.
yeah, samples. I just put right at same time samples. And these samples have the two column. So first column NDVI, and in this time I want to predict KC. Okay, KC is for depend. So depend column, you just put the this bracket, okay, this, and put the column name KC, because KC is the defend on the NDVI. Okay, so just I put it, and then you can also apply chart type. Suppose I want to create the scatter chart, so put here the dot set chart type. Okay, set chart type, put here the scatter chart. Okay. And then also add the suppose title, so put here the set options to add the title. So I put the title in NDVI versus KC. Then put here suppose X level, Y level title, X axis, NDVI, and vertical axis. Put the title is it's mainly your KC. Print the chart. So now run them. So I create the other chart. So you can see find out this type of trend. So it show that you can see positive trend you find out in here. Okay. And you can also download the data. And further you can also use it to identify for make the R square value or correlation value using the Python. Same process. Just import the CSV file. Okay, to identify accuracy or other things. It also possible. So this is the one another way. We can also get this type of things from here to make the scattered chart. Okay. And finally, if you want to, another thing is that for the time series chart of the KC, every image. So in this time we create the time series chart, not for every image. So it also possible the another way. We can also compute the time series chart. This I think it was more perfect. So let's go. I show you the process also. Take a variable, suppose AOY. I take a point, suppose EE dot geometry dot point. Just a minute. Refresh it. That was 32.0 and that was 30.60. And I take the buffer. So put here that buffer, suppose 400, 4 kilometer, 4,000 meter. I put center object. Suppose this is my study area. So I want to identify for KC. So just I apply the same code, just I copy. Just I copy the same things from here. Okay. So we find out this type of result. So now we just simply check time series chart of mean KC over AOY. Every image we try to compute every image in the period. Okay, so for that we need to compute the average KCI value for every image. So take a variable, suppose we just create a function. Okay, so once I put the variable name, suppose TS, and create a function, I put the function name, suppose IMG, and now we compute the every image's average value. So take a variable, suppose mean, and call the IMG, apply the reduce region, and put the reducer ee dot reducer dot mean to compute average KC for every images. Then put here geometry, basically AOY. Then scale is a 10 meter. Okay, so now this is the function. This function we need to connect with our data set, our image collection. So S2, I simply call the S2. Just connect. From the S2, we simply select the band of KC, okay, and connect. So let's put here the dot map function, just connecting. So now it's help you to compute every single image's average value of KC. Okay, so now we simply define dot get KC, and what we return? So we return ee dot feature, basically it's a null feature, put the null, and from here we just extract the two information, date and value. So just we put here date, ee.date, and this date it's come from system time start. Just define system time start and put the format. I put the format date format, suppose year, month, and date. Okay, then another column, it's called that kc mean. I put kc mean and put the mean. Okay, so we simply return this function. So now if you print, suppose just print the ts and run the code. Okay, so it shows the dictionary. Image. Okay, so it's a get. So if you check, we can get the feature every images average value. So you can see for this time we find out this value, kc value, average kc value for this time. Also you can see for this time we find out this kc value. Okay, so now this thing we simply represent as a chart, then it look more perfect. Then we can easily get that which time it's need the more water demand. Okay, which time we find out the high kci value, we can easily get this idea. So for that, simply get the result, check a variable, suppose chart, and apply ui dot chart feature dot by feature, and then call the ts this variable, and I want to put the date. Okay, and I want to define the value, so put here the kc dot mean. So kc, this column kc dot mean, okay. Now if you want to also put here, suppose dot set chart type. I put the chart type, suppose line chart, and also add, suppose set option to add title. I'll put here those mean kc value aoy. Then put here, suppose horizontal axis, x axis, put the title, it's a date, and also vertical axis, it's a kc value or kc dimension. We can also put here, suppose just let me show you the chart, print the chart and run the code. So we find out this type of chart if you check. Okay, so if you want to also look more perfect, suppose I want to put here the point size, so we'll put here the point size, define the point size, suppose 3, and also identify, suppose line width, I put here suppose 2. Now run the code. So now from here you can get the idea when we need the more core water demand, okay, based on the kc value. for this area. Okay, so we find out this type of chart, you can see. So we calculate. Yeah, please.
What is the difference of that time series of chart feature by feature and that we use UI.chart.series?
Okay, so basically this is the feature by feature, means that you can see we make the chart from this feature. It's a feature collection, you can see. So I have a feature, you can see it's feature. Okay, this type of feature we just represent. In this feature you can check, I have this column, KC mean column and also date column. So I want to represent this feature as a chart. Okay, so feature by feature means that when you make the chart from the feature. Okay, so in this time I have a feature, so it's a feature, not image, it's a feature. Okay, but this data we generate from the image and convert into feature collection. You can see ee.feature. So now this data, it's come from this our, you can see satellite Sentinel-2 satellite imagery from the KC band. We get the data, we compute average KC value for our study area for every images. Okay, and it make the feature collection and store it in this variable. So now from this feature I want to make the time series chart. So for this, again, I have the date. I already get the date from this function. I can get the date and also get the KC mean value. So this thing I simply represent as a chart using the feature by feature function. So now we can easily get the more better chart to identify. So you can see which date I need the more crop demand of water. So we find out that 2025 26 February. So this time for my study area, crop water demand is very high, because in this time I find out the average value is very high. So now for this time my crop plant area need the more irrigation for this time. Okay, also you can see for this time need the low irrigation. For this time I need the low irrigation. For this time I need the low irrigation. But this type of time you can see it's very high value, also this high value, also this high value. So this type of high value for this time, for my agricultural land or crop plant, I need the more demand of water. But you can see for this time or for this time it's very low, KC value is the low. So this time I don't need for the high irrigation of my cropland area. So this is the overall scenario from where you can get the idea when mainly your irrigation schedule. We can get the idea about the irrigation schedule. When you need the more crop demand of water, we can get the idea. So we can get the idea from here, overall idea. Or overall data set from here, we can get from here. Okay. Okay, any question you can ask me, please.
I don't have a question. Maybe to help me to know if I have CSV file of NDVI column and KC column in Google Colab. How can I
Okay, understand.
add this?
Okay, very easy. Just you can see. So I'll show the random example. I already have the CSV file in my.
Yes, random.
Yeah, just a minute. So this is a CSV file. Suppose this is the CSV file. So when you work with the CSV file, we need to import the another library. It's called the pandas. Okay, pandas.
Yes.
As PD. So now I want to this file. I simply just copy from the, you can see the copy the path, and I put the variable name, suppose path, and then store it this file in this path. Okay, just I run. So now I want to read it. So suppose I put the variable name is the df. So df I call the PD, dot read CSV. Okay, and this CSV is stored in the path. Just run it. So now I just call the df and run. So you can say I can get the data. So now I want to work with, suppose this is, and this suppose suppose target, or suppose this one, or this slope. So any two column. So again, there's a lot of column, but I want to work only for the two column. So I need to simply separate the column. Suppose I take the one column is, okay, I simply call the S column. So just call the df and put this bracket and call the S column name. Okay, so now what happened? Oh, sorry. So df, suppose I call the X, I take the variable, suppose is, okay, and call the df. It show the df, and then I simply select the column name. Okay, so now I find out the S. Okay, you can say only for the S column I separate. Suppose I take the another column, suppose 6, just I simply separate column, or CP. So for the CP, what can I take the variables of CP and then call the df, sorry, call the df and apply the column name, suppose CP. So now I just print the CP, just I separate. Okay, I print CP. Suppose I want to, suppose this is, so it's my, suppose, independent, and CP is the dependent. So for the independent, we need the reshape.
Yes.
So just simply put the dot reshape function and apply -1 to 1. Just make the reshape.
Oh,
just
reshape for independent or dependent?
Independent, mainly X variable X. Okay.
Okay.
For the reshape, just a minute, let me check. I think for the reshape we need to import the numpy function. Okay, array, numpy array. Okay, so now you can see previous time we just simply apply the array, numpy array, and put the reshape. So in this case we need to apply the numpy array and also reshape. Okay, so just we simply put, suppose, dot or I just put in here, suppose, dot np dot array, or is dot np.
Sir,
Yeah,
you have to create a new variable.
Yeah. Suppose np dot array, and I just call the is, okay, and put here the reshape. Okay, so now it's the reshape.
Okay.
So now it's the reshape. So now for the same process, just simply apply when you work with the CSV. And so you can get that.
If you don't reshape,
then it not work. Okay, so this is the all time. Basically, when you work independent variable must reshape. Okay, reshape. Basically, for the reshape, we just make the 1D array. Okay, it must always, okay, for the independent variable. Okay, suppose X is independent, so you must make the 1D array. But when you work with dependent variable, not need. Okay, others keep the same process to work with.
Okay, sir. Thank you.
Okay. As well as, okay, so another thing is that we can also download this type of chart. Yeah. So this chart I want to download, okay, as a PDF or also JPG format. So it's very easy. Just we can simply write the code. Suppose just take the new cell, or you can also click and save it easily, but it's not the proper way. Okay, for the proper way is that we simply call the plt dot save save fig, just save fig. Then simply define the location of your file. Suppose I want to save it in this location, so you can simply copy any file path. Suppose just I copy this path and paste here. So from here I simply, okay, so oh, it's a default, okay, default. If you don't mention any file, any path, it automatically save. Just simply define the file name. I put the file name, suppose ndvi and kc chart. Okay, then put the comma sign, put the comma sign and put the DPI resolution, keep 300. Okay, and then run the cell. Okay, so now this figure is saved in this folder. So now find out where is the save, ndvi kc. Yeah, ndvi kc, you can see this is the result 5 seconds ago. Okay, so this is the way we can simply identify. Suppose when you put the PDF, just simply change it. Okay, just put here dot PDF, okay, or put JPG. Then we find out the PNG. Okay, but then we find out the PNG. Suppose PDF, and also put here when you put the PDF, then also change it. Simply put here it show the result for BB box Indices. Put here tight. Okay, so now run the code. So now it's saved. Okay, if you check it, the PDF file, where is it saved? ndvi kc chart PDF. Yeah, so this one you can see the PDF file. Okay, we find out this PDF, but why it's not showing the chart? Okay, bbx. Okay, this is the chart. Let me remove it. Or I need to run it before the plot show. Yeah, sorry. Okay, before the plt show, you can put the saving code. Okay, so now check again. Where is it saved? Yeah, this one. Now you can see we can get the chart. Okay, so before the plt show, okay, before this code, simply write the save code or png or tpg, then it will be saved as a PDF format. So I hope you also get the idea how to save this file after making the chart, and also PDF or JPG or PNG. So you also try. Okay, so I also send you all of code. You try to practice also real data. Okay, then it look more better or perfect result you can find out from here. Okay, so today is no more. I will send you all of those as soon as possible.
Yes, sir.
Okay, thank you. Have a good night. Bye.